we have talked about sequences, which are ordered list of numbers. So now let's take it one step further and talk about something new, a series. Okay, what is a series? A series is what you get when you take the terms of a sequence and add them together. While a sequence might look like A1, A2, A3, A4, likewise, a series will look like A1 plus, A2 plus, A3 plus, A4 plus, and so and so. So this is a sequence and this is a series. So this is the difference between a sequence and a series. So a series is a list of numbers which is in a order, and a series is what you get when you take the terms of a sequence and add them together. So sequence will look like this, a series will look like this. That's it. So a series is sum of a sequence. Okay, so there are two types of series, a finite series and an infinite series. So first of all, let's talk about finite series. So a finite series adds up a limited number of terms. For example, it looks like 2 plus 4 plus 6 plus 8 plus 10. So here this is a finite series. It's because here you have finite number of terms. So specifically you have 5 terms here. So you can calculate its sum exactly. So we often use the sigma notation to write it compactly. So this one over here, we can rewrite this with the sigma notation. So n starts with 1 uh, and it goes, okay, let's say k. So let's k starts from 1 to n, and you can write this like this in a compact notation. So this means you have to add up uh, n terms of this sequence. On the other hand, infinite series means you are adding the terms forever and it will never end. For example, let's say you have a series like this: half plus 1/4 plus 1/8 plus 1/16 plus and so and so. It goes on forever. So this is an infinite series. It is an infinite geometric series. You'll learn about geometric series. So here each term is multiplied by one half to get the next one. So sometimes, even though there are infinitely many terms, the sum approaches to a number. So we call this is the limit of the series. So quick summary, a series is the sum of a sequence, and a finite series has fixed number of terms. An infinite series keeps going forever and may or may not have a finite sum. So that's all about series. So let's try some examples. Okay, so let's learn how to evaluate summation. Let's do this step by step. So we are looking at this summation sign. So this symbol over here, it is a Greek letter for sigma. This means we are going to add up several terms in this expression. So what does this mean? So let's try to break this down. Okay, so here in the bottom of the sigma, it tells us the n starts with 1. N starts with 1. And top tells us to go up to n equals 4. And the expression to the right is 2n negative 1 is what we are plugged in for each value of n. So next step is, so we will plug each value of n from 1 to 4 into this expression, and then we're going to add up the results to get the answer. So let's start with n equals 1. So what I'm going to do is I'm going to substitute n equals 1 into this expression. So it's going to be 2 multiplied by 1 minus 1, which will result 1. And next I'm going to substitute n equals 2 into my expression. That will give me 2 times 2 minus 1, which is a 3. Then n equals 3. 2 times 3 minus 1, it's going to be a 5. Then when n equals 4, it's 2 times 4, 8, minus 1, 7. So we have the terms. So now you have to add all these 4 terms. So this implies you have to add 1 plus 3 plus 5 plus 7. So if you use your calculator, or if you do this calculation, you'll end up with 16. So final answer, if you evaluate this summation notation, you'll get 16. So the summation gave us the first 4 odd numbers like 1, 3, 5, 7, and the formula to n minus 1 actually generate those odd numbers. So we were just adding the first 4 odd numbers, which is equals to 16. Okay, so this is the first example I wanted to discuss. Next, I want to talk about this. Okay, so here, this is an example for a finite series. So you're asked to find the sum of the first 6 terms of this sequence. So here you're given only first 4 terms. So you have to evaluate 2 more terms, and then you have to add all 6 terms. Okay, so first term here we have is 6. The second is 3. Third 3 over 2, and fourth is 4 over 3. So once you see this sequence, you will see that each succeeding term of this sequence is found by multiplying the preceding term by half. So if you multiply 6 by half, you'll get 3. So if you multiply 3 by half, you'll get 3 over 2. And if you multiply 3 over 2 by half, you'll get 3 over 4. So in order to get the next 2 terms, what I'm going to do is I'm going to multiply the term 3/4 by half. Okay, so to get the next term, what I'm going to do is I'm going to multiply this term by half. Then you'll get 3 over 8. To get the next 6th term, I'm going to multiply again this term by half. So it's going to be 3 over 16. And then I'm going to add all these 6 terms. So now you can use your calculator. So if you add all these 6 terms, you will end up at 189 over 16. Okay, so this is how you do, how you add first few terms for a given sequence.